Hi there, it's Professor Myers. Here's a solution to one of the trig problems from the homework. It can be a little bit on the tricky side. So let's check it out. So for this one, we're basically going to add cosine at x to both sides. And we'll get a result of cosine cubed at x plus cosine at x is equal to 0. Now we've got a common factor of cosine at x. We can't just divide out a cosine at x because it's going to leave out the solution where cosine at x could equal to 0. So we're going to factor out cosine at x and we'll be left with cosine squared at x plus 1, and then we have it equal to 0. So we'll get cosine at x is 0, or cosine squared at x plus 1 is 0. Now on the unit circle, for the cosine function to have an output of 0, we have to figure out which quadrantal angle has no run. The cosine function is really your x-coordinate of the unit circle. So if we have, this is 1, 1, 1, negative 1, and negative 1. We've got our circle here. Not a very good circle. Got our unit circle going. And so what will happen here is that just any random ordered pair is going to be of the form cosine at x, sine at x. Right? So we want to figure out where the cosine at x is 0, right? We need to have this entry be 0. Well, when is your x value 0 at the angle? We would have an ordered pair here. Do you see that this would be the ordered pair 0, 1? And this here would be the ordered pair 0, negative 1. Now we just need to figure out what those angles are. So this angle here is pi over 2, and the other angle is 3 pi over 2. Actually, I should do that in a different color. So those will be our solutions to our first equation. X will equal to pi over 2 and 3 pi over 2. Now this next one, what's going to happen is when we get the 1 over to the other side, we'll have cosine squared at x is negative 1. Now if you were to square root both sides, you'll end up with cosine at x is going to be plus or minus root negative 1. Right? And actually, the plus or minus happens right away. And this is imaginary. Okay, so we'll just get this answer here, pi over 2 Actually, my bad. You just get pi over 2 and 3 pi over 2 as the angles that will satisfy the equation. All right. Have a great day. Bye.